So what we're going to work on today is basically some algebra review that's necessary for Chapter 10. Chapter 10 deals with circles, and when we start dealing with circles, we're going to start getting some quadratic equations, which means polynomial equations, which means we have to remember how to FOIL and factor. So just a real quick review of some stuff from Algebra 1 for this. I don't think you'll find it too difficult, but it's good practice. Reminder that FOIL stands for first, outside, inside, last. And it's an acronym we use to help remember how to multiply binomials. Binomials are in the form of ax plus b and cx plus d. So that's a binomial. So when we're multiplying these, we multiply the first in each group. So 3x times x is 3x squared. Then the outside, so 3x times positive 6. Now we have to pay attention to sign. Really important. So that's plus 18x. Then the inside, which is negative 4 times x. Now remember, the negative sign here goes with the 4. So that's minus 4x. And the last, negative 4 times positive 6 is negative 24. And we combine like terms as is possible. Usually it's the outside inside that wind up combining, and that's the case here. So plus 18x minus 4x is plus 14x. So 3x squared plus 14x minus 24. And I've FOILed out those binomials. Let's try again with x minus 8 and x plus 2. So first, x times x is x squared. Outside gives me plus 2x. Inside gives me minus 8x. And last gives me minus 16. So that's x squared minus 6x minus 16. And I'm sure you remember, because it's leading into where we're heading next, that negative 8 plus 2 is negative 6. Negative 8 times positive 2 is negative 16. So we see those values showing up kind of in the polynomial when we have leading coefficients of 1, when I don't have a number in front of the x's. So those are nice. A couple more examples, then we'll move on to factoring. So x minus 7, x plus 7, again, first, x squared outside plus 7x inside minus 7x, and last minus 49. The outside inside actually cancel out, leave me x squared minus 49. Now you'll remember this as being called difference of perfect squares factoring, because x squared is a perfect square and 49 is a perfect square, and it is a difference minus. So that's a difference of perfect squares. And it's always in that form of a minus b, a plus b, or a plus b, a minus b. That outside inside is going to cancel out when we see that. Those are nice. X plus 5 squared. This is one that people mess up all the time, because what they want to do here is they want to distribute that exponent and just say it's x squared plus 25. But that is exactly wrong. Don't do that. Okay? X plus 5 squared literally means x plus 5 times x plus 5, which we have to FOIL out. X times x is x squared. X times 5 is plus 5x. Inside gives me another plus 5x. Those are not going to cancel out. And the last gives me a plus 25. So I do get an x squared and a 25, but when I distribute the x, I lose the outside inside terms, because this is really x squared plus 10x plus 25. Okay? So you got to be careful with that. You cannot distribute an exponent over a sum or a difference. Okay? That's one of our little exponent rules that we learned a long time ago, that a times b to an exponent is a to the exponent times b to the exponent. We did that already this year when we did, say, 3 root 5 squared is 3 squared times root 5 squared, which is 9 times 5, or 45. Okay? We've done that. However, a plus b to the n does not equal a to the n plus b to the n. Okay? It does equal a plus b times itself however many n times. Okay? So the rule that does apply, happy face for that, is a frown face down here. We cannot distribute an exponent over a sum or a difference. I can distribute an exponent over a product or quotient. Okay, the opposite of FOIL is factoring. And the method we're primarily going to use is the product sum method. We're going to keep it to fairly straightforward factoring. But again, what we do is we look at our terms of my polynomial. Okay? My polynomial, if I have a leading coefficient of 1, which I do here, so the coefficient of x squared is 1, I look at the plus 8 and I look at the plus 15. Okay? And the product sum rule tells me that I need two numbers that have a product of this last number here. So whatever my two magic numbers are, we'll call them magic numbers. We'll say a times b has to equal 15, and a sum of this middle term, so a plus b has to equal 8. I got to find two magic numbers that give me a product of 15 and a sum of 8. Now, they're both positive, which is really nice. They're going to be two positive numbers. Since the product is positive, I know the two numbers have to have the same sign. Since the sum is positive, I know both those signs have to be pluses. And pretty clearly, most of you have probably been screaming in your heads already, it's 5 and 3. You're right. And now we just factor, it's just x plus 5, x plus 3. That's how it factors. It's FOIL backwards. Okay? Here, x squared minus 10x plus 21. Again, just to highlight quickly, my sum has to be negative 10. My product has to be positive 21. So again, if we go back, I'm sorry, wrong tool. There we go. So a times b is positive 21. A plus b is negative 10. The clues tell me, since the product is positive, that the two numbers must have the same sign. A positive times a positive or a negative times a negative. Since the sum is negative, both those terms must be negative. So what two negative numbers, sum of 10, product of positive 21? Well, it's negative 7 and negative 3, fairly obviously. So it's x minus 7, x minus 3. And again, negative 7 plus negative 3 is negative 10. Negative 7 times negative 3 is positive 21. Let's practice a couple more. X squared minus 4x minus 21. Okay? Now I've got a negative product. Product equals negative 21, and the sum is negative 4. I need magic numbers that multiply to give me negative 21 and add give me negative 4. Well, 21, that could be 21 times 1 or 7 times 3. Those are pretty much my only choices. But since it's negative, one of them has to be negative. Since the sum is negative, the larger one needs to be negative. So 7 and 3 are my magic numbers, and it's negative 7 and positive 3. Because negative 7 plus 3 is negative 4, and negative 7 times 3 is negative 21. X squared minus 64. You're saying, well, wait a minute. My product is negative 64, but what's my sum? I don't have a term there. You're right, we don't, so the sum is 0. So I need two numbers that multiply to give me negative 64 and add to give me 0. They must mean the same number, positive and negative, to have a negative sum, or a 0 sum. So that must be 8 and negative 8. Which is a difference of perfect squares. We saw that in multiplying. Now we're seeing it in factoring. All right, so we've FOILed, we've factored, we have one step left, and that is solving. Okay? This is kind of an all worked out example for you. It says, suppose we have the polynomial x squared plus 3x minus 40 equals 0. When a polynomial is set equal to 0, first we factor the polynomial, and then we use that to solve for x. So now instead of just factoring, we're solving for x. Now, a lot of this is going to work the same way. We're still going to do our product sum rule. Our product is negative 40, our sum is positive 3. So my magic numbers are 8 and negative 5. So I factor the polynomial into x plus 8x minus 5 equals 0. But here's where the zero product property of algebra comes in. If two numbers multiply to equal 0, one of those numbers or both of them must equal 0. 0 is the only number for which that works. And if two numbers multiply to equal 6, it doesn't mean that one of the numbers must be 6. Could be just 2 and 3 give you 6. Okay? But with 0, if two numbers multiply to give me 0, one of those numbers or both of them must be 0. So that means either this x plus 8 right here must equal 0, or the x plus minus 5 right here must equal 0. So we solve those little mini equations, which is pretty obvious. Subtract 8 from both sides, x equals negative 8. Add 5 to both sides, x equals positive 5. So we get our solutions. And you notice our solutions are the inverses of our magic numbers. My magic numbers were 8 and negative 5. The solutions are negative 8 and 5. Now, this works pretty consistently, so go along again, as I don't have a number in front of the x squared. If I have a number in front of the x squared, it gets a lot more complicated. We're keeping it fairly simple today. No number in front of the x squared. So let's solve these. Again, we're going to factor what's here on the left first. So my product is 24. My sum is 12. What two numbers multiply to give me 24 and add to give me 12? Actually, nothing. So I made a mistake on this one. I'm sorry. That should have been an 11. There we go. So let's make that an 11. Much better. What two numbers multiply to give me 24 and add to give me 11? That would be 8 and 3. So x plus 8, x plus 3, equals 0, because positive 8 and positive 3 are my magic numbers. So that means if that's true, that we're the opposite of these, x equals negative 8 or x equals negative 3. Because I put negative 8 in, I get 0 times negative 5, which is 0. Put negative 3 in, I get 5 times 0, which is 0. Okay? X squared minus 9x minus 22 equals 0. So again, I have to factor first. So it's x and x. My product has to be negative 22. So that must mean either, I don't have a lot of choices for 22. It's 22 and 1 or 11 and 2. The 11 and 2 are going to give me the 9. Which one has to be negative 9? That would be negative 11 and positive 2. So I've done my factoring, and now I have to solve. So that means x equals the opposite, so negative 2. Or x equals the opposite of negative 11, which is positive 11. And we found our solutions. So your assignment for the rest of the day is going to be work on a worksheet that is full of problems like this. First, you'll be foiling. Okay? Then you'll be factoring. Then you'll be solving. And all these are skills we're going to need in Chapter 10. So you'll be getting your worksheets now. Be working on those in class, and we'll see you when you get back from break.